Next is a reflex klystron. When you see the structure, it consists of electron gun, anode cavity, repeller electrode, and the anode voltage and repeller voltage, and the RF output. And we have the space between the repeller electrode and the anode cavity is denoted as repeller space. When you see the operation of this electron gun, the function of electron gun is that it generates electrons continuously. The generated electron, it move towards the repeller electrode. It move towards the repeller electrode. Before that, if you see the connection, this electron gun is connected to the negative of the anode voltage, and when you see this repeller electrode, it is connected to the negative of the repeller voltage. So the generated electrons from the electron gun, it move towards the repeller electrode. So before it crosses this anode cavity, so few gets accumulated to this anode cavity and few it move towards the repeller electrode. Since the repeller electrode is connected to the negative terminal, the electrons which move towards the repeller electrode, it gets reflected in it reflected in the sense it gets accumulated in the anode cavity. So there will be the creation of bunch of electrons in this anode cavity, which is the thing for generation of RF output. So when you see there are three parameters in this ER and EL. E is nothing but early electron, ER is nothing but reference electron, and EL is the late electron. When you see EE, that is early electron, its acceleration force is less, and since because of that the velocity is also less. And when you see the late electron, the acceleration force is high and the velocity it also get increased. That means the late electron, it reaches very fast, and the early electron, when you see the acceleration force, it is very less. So after a fixed time period, all the electrons get bunched at fixed position. For better explanation, when you see this this graph, this is the electron bunch position, and this is the early electron, reference electron, and late electron. So these are the electrons which are generated by the electron gun continuously. So when it gets reflected due to this repeller electrode, it all this accumulate, it all bunch together in the at one position in the anode cavity. So this is the representation of this. And when you see this representation, TR, transition time, it is equal to T of 1 plus 3 by 4. This late electron, it will move very slow when compared to the this early electron, it moves very slow when compared to the late electron. If the early electron is less than the reference electron, and the reference electron is less than the late electron, so the bunching of electron by setting the modes of propagation in klystron tube, by setting the here this n, Tr is equal to T of n plus 3 by 4. This n represents the number of mode number, and T is nothing but the time period. So while providing different velocity for different electron, there will be the bunch of electrons at one fixed position for the generation of the RF output. When you see this here, when you see this is a TR of 1 plus 3 by 4, TR of 2 plus 3, these are 1, 2, 3, 4, these are the mode numbers. This is the representation between anode voltage and repeller voltage. If we change VR and VA, that is repeller voltage and anode voltage, we can observe the signal transformation. When you compare the performance parameters of reflex klystron, the frequency ranges is between 4 to 200 gigahertz, and the output power is between 1 milliwatt to 2.5 milliwatt. Sorry, 1.1 milliwatt to 2.5 watts. And when compare the efficiency theoretically it is 22.78 percentage, and the efficiency practically is that 10 to 20 percentage, and the tuning range it lies between 5 gigahertz to 2 watt to and 30 gigahertz to 10 milliwatt. When you see the application of this reflex Klystron, it is used for used as oscillator, amplifier, and for microwave source such as reflex Klystron.